दो मुझको पढ़ने वाला, दो स्टेप कहाँ है? हाँ यार थोड़ा सा कर लो। उसको लेमिनेशन मतलब तो मैं अपना कुछ देख लूँगा। मैं देखो, देखिए लाइव दिखाओ, सर्च करो क्या? खून क्या होता है? अरे हाय देखा ऐसे मर रहा है। अच्छा रुको, मेरे में क्या दिख रहा है? खुलते हो? ये काम करिए। नहीं उसी लिंक पर क्लिक करो। अरे तो दिखा, क्या दिखा रहा है? मुझे बहुत आवाज आती है क्या? हेलो, हाँ तो कल लाइव है ना, चलो खाना नहीं तो ये नहीं दिखा रहा है, अपने कपड़े बीचों में नहीं दिख रहा है। चलो अब देखो, अब पूरा आ गया होगा। तुम ज्वाइन की हो, कुछ लाइक कुछ किए हो? काहे तो हुआ नहीं दिखा रहा है। लाइक करो, एक तो लाइक करो, लाइक करो, कटा नहीं है ये। लाइक करो मेरे को, कब दिया? हाँ एक हो गया। भेजे तो हैं, थोड़ा काल के जो हेरा के तो दिखा हो ऐसे गलत। ये हमारा काशी हिंदू विश्वविद्यालय का प्रेजेंटेशन है। ये डॉक्टर सुनील कुमार सिंह प्रोफेसर एंड अरुण प्रताप मौर्य MSc BEd। तो फ्रॉम हम सोच रहे हैं कि पढ़ा जाए कुछ ढंग का, इसलिए हमने एक अपने स्टूडियो सेटअप पे टैब लिया है और एक लैपटॉप और स्टैंड और इस तरह से हम हमेशा से करते हैं। और ये हमारा लैपटॉप है, ये हमने ऑन कर दिया। आ रहा है, आई आई वरुण को करो, वरुण कॉल लगा के हमको दे दो। कॉल करें? हाँ हाँ बोले व्हाट्सएप कहीं व्यस्त ही नहीं है ससुर। तो हमने सोचा कि क्यों ना आज अच्छे से पढ़ाई की जाए, तो इस तरह से हम अपना माइक्रोसॉफ्ट एज खोल लेते हैं। हाँ ठीक है, कहाँ बाहर नहीं जा रहा है। क्यों हवा क्यों नहीं आ रहा है? अच्छा पानी भरा रहे हैं। बरनुआ नायब के है।
बेटा ब्रेकफास्ट में फ्रूट्स नहीं, ओट्स, आलमंड्स, सीड्स, ये सब और रागी, व्हीट, कॉर्न, रेजिन्स, ब्लैक कर्रेंट्स, क्रैनबेरीज, इतना सारा बस 12। केलॉग्स म्यूसली है 12 ग्रेन्स, फ्रूट्स, नट्स एंड सीड्स वाला पावर ब्रेकफास्ट। केलॉग्स म्यूसली 12 in 1 पावर ब्रेकफास्ट। क्या आपको पता है इंडिया में कितने % लोगों को स्टॉक मार्केट में लॉस हुआ है? 93%। बता रहा है यार, क्या करोगे आप जान के इस डेटा के बारे में? यूपीएससी की एग्जाम देनी है।
अरे बरनो करो तो कॉल तो करो।
मन में राम रे, तन में राम रे, रोम रोम में राम रे।
दिख रहा है
मन में राम रे, तन में राम रे, रोम रोम में राम रे। लील सुमिरन राम नाम
नाम का बिगड़े बन जाए काम। हाँ बोलो राम, हाँ बोलो राम, जय श्री राम। हाँ बोलो राम, हाँ बोलो राम, हाँ बोलो राम, जय श्री राम। हाँ बोलो राम। यार काटो। हेलो, एक लिंक भेजा हूँ, ओपन करो यूट्यूब व्हाट्सएप पे। कहिए चला ठीक रखा था तो बताया व्हाट्सएप पे। हाँ राम नाम का मधुर तराना मुख में हर पल साथ चले। बिखरे बन के सोने आंगन तेरी दया से फूल खिले। देखो वो पीछे चल रहा है, वो आगे चल रहा है, देख रहे हो दोनों अलग अलग। प्रभु तुम्हारे चरण कमल से भाव सागर से पार। नहीं अच्छा हाँ फिर से लाइव देखते रहो, दो लोग हैं। चरण कमल से भाव सागर से पार लगे, भाव सागर से पार लगे, भाव सागर से पार लगे। मन में राम रे, तन में राम रे, रोम रोम में राम रे। मन में राम रे, तन में राम रे, रोम रोम में राम रे। लील सुमिरन राम नाम का बिगड़े बन जाए काम। हाँ बोलो राम, हाँ बोलो राम, जय श्री राम। इसको चार्जिंग चाहिए। हाँ बोलो राम, हाँ बोलो राम, मेरे साथ चले। प्रभु तुम्हारे चरण साला मेरे जगह पंचर हो सागर से पार लगे। प्रभु तुम्हारे चरण कमल से आओ सागर से पार लगे, आओ सागर से पार लगे, आओ सागर से पार लगे। पगला जाए पर मन में राम रे, तन में राम रे, रोम रोम में राम रे। मन में राम रे, तन में राम रे, रोम रोम में राम रे। लील सुमिरन राम नाम का बिगड़े बन जाए काम। हाँ बोलो राम, हाँ बोलो राम। अच्छा आवाज नहीं आ रही है? नहीं उसका उसमें आ रहा है ना। हाँ बोलो राम, हाँ बोलो राम, बोलो राम, जय श्री राम। हाँ बोलो राम। तेरे नाम की शीतल छाया तपते मन को छाँव मिले। शरण में तेरी शीश झुकाए प्रेम सुधा बरसात मिले। तेरे नाम की शीतल छाया तपते मन को छाँव मिले। शरण में सुनहरी जर जतन आराम में, तेरी याद की धूप सुनहरी जर जतन आराम मिले, जर जतन आराम मिले, जर जतन आराम मिले। मन में राम रे, तन में राम रे, रोम रोम में राम रे। मन में राम रे, तन में राम रे, रोम रोम में राम रे।
official Roll Esports mod from GX Store to unlock bonus con features. Browse the collection and choose a mod. Open GX Corner and scroll to the Riot section with a brand new co-streaming hub. Set your language and choose a stream. Only on the browser for games. Only on Opera GX.
चले गए। दो लोग दिखा रहे हैं।
प्रेम के रंग में हरि नाम संग में लीन हो जाऊं ना।
चलो बंद करो।
We humans are the most intelligent creatures known to have ever appeared in the universe. What are humans made of? The human body is composed of organs, bones, blood, nerves, and more. Take one of the organs, the heart, and if we zoom into it deeply, we can see billions of cells. But the cell isn't its final stage. Again, if we zoom further into a singular cell, we'll end up with molecules. In just this one cell, there are millions of unique complex molecules. called elementary particles or fundamental particles. Quarks are elementary particles, but there are a further total of 12 matter particles and 4 force carriers in the standard model of particle physics. So what classifies something as an elementary particle? If we look at the proton, it consists of 3 quarks. However, it's more precise to say quarks collectively form a proton rather than a proton contains 3 quarks. So protons are not elementary particles. They are subatomic particles. Elementary particles don't have any substructures and cannot be broken down into smaller components, which means they aren't made up of any. Anything. These are the final and smallest known building blocks of our universe. The study of elementary particles is called particle physics. Studying and understanding these particle forms the foundation of both classical and quantum physics. So let's return to the standard model. There are 12 matter particles and 4 force carriers classified into 3 families: quarks, leptons, and bosons. Quarks and leptons are together called fermions. All elementary particles have 3 basic properties: mass, spin, and charge. If we look at the first particle, it has a mass of 2.4. Fermions. All elementary particles have three basic properties: mass, spin, and charge. If we look at the first particle, it has a mass of 2.4 mega electron volts divided by c squared. Mass of an elementary particle is mentioned as energy. It comes from Einstein's mass-energy equivalence equation, E is equal to mc squared. For example, if we convert 1 gram of mass into pure energy, it becomes 5.6 into 10 to the power of 31 mega electron volts. So from here we can compare the mass of the particle with 1 gram's energy. In the realm of particle physics, fermions are generally characterized by half-integer spins, while bosons typically possess integer spins such as 0, 1, or 2. However, be careful. Although we use the word spin, it's not the same as the spinning of a ball. First, we start with quarks. There are up quarks and down quarks, and each of them come in 3 generations. So in total, we have discovered 6 flavors of quarks. The up quark has a charge of plus 2/3, while the down quark carries a charge of minus 1/3. This same charge is continuous in their subsequent generations. Plus 2/3, while the down quark carries a charge of minus 1/3. This same charge is continuous in their subsequent generations. There is no major difference between the generations, though each generation tends to be heavier than the previous one. We've already heard that though each generation tends to be heavier than the previous one. We've already heard that a proton has a positive charge. That charge is simply composed from the charges of the quarks. A proton is composed of 2 up quarks and 1 down quark. So the combination of charges comes as plus 2/3. Plus 2/3 minus 1/3, which is a total of plus 1. Similarly, a neutron is composed of 1 up quark and 2 down quarks. and the combination of charges minus 1/3 minus 1/3 plus 2/3 totals 0. So the neutron comes with neutral charge. The combination of 3 quarks is called a baryon. Therefore, proton. Protons and neutrons, a combination of 3 quarks is called a baryon. Therefore, protons and neutrons are baryon particles. Now we can Therefore, protons and neutrons. The combination of 3 quarks is called a baryon. Therefore, protons and neutrons are baryon particles. Now we can baryon. Therefore, protons and neutrons are baryon particles. Now we can see that the same flavor of quarks exist in a single baryon particle. For example, a proton has 2 up quarks. Now, how do we distinguish them? That's where an additional property comes into play, which is the color charge property.
दूध लेंगे
And how do these 3 quarks bind together? It's also related to the color charge property of quarks. Each flavor comes in 3 colors: red, blue, and green. However, don't let these colors mislead you. Quarks are much too small to be visible and thus could never have a visible property like color. The names were chosen because of a convenient analogy. Quarks are much too small to be visible, and thus could never have a visible property like color. The names were chosen because of a convenient analogy. In a proton, there are 3 quarks, one of each color, and they constantly exchange colors among themselves. But how do they exchange colors and interact? That's where the messenger particle, or force carrier, gluon, comes into play. Quarks are able to change their color during their interactions. The gluon acts as a messenger particle, carries a color charge from one quark to another, and facilitates interactions between quarks. So gluons hold quarks together by exchanging color charges. Since gluons are massless, they exchange colors between quarks at near the speed of light. However, the same color cannot exist simultaneously in 2 quarks. For example, in a proton, if one quark has a red color, the remaining 2 quarks will have green and blue. If one quark has a green color, the other 2 quarks will have red and blue. Thus, 3 quarks in a baryon particle always have different colors by exchanging gluons. If we combine the red, blue, and green colors, we end up with no color. Therefore, the proton is a colorless particle. All baryon particles are colorless. We've already heard about the strong nuclear force. That force is simply the color charge that involves the exchange of gluons between quarks, binding quarks. Therefore, the proton, as 3 quarks in a baryon particle, always have different colors by exchanging gluons. If we combine the red, blue, and green colors, we end up with no color. Therefore, the proton is a colorless particle. All baryon particles are colorless. We've already heard about the strong nuclear force. That force is simply the color charge that involves the exchange of gluons between quarks, binding quarks together and creating the strongest force in the universe. Even though it's the strongest force, its range is only a few femtometers. 1 femtometer equals 10 to the power of minus 15 meters. We've already seen that protons have a positive charge, but how do protons stick together in the nucleus? While the same electric charges repel each other and opposite charges attract each other. This is also caused by the strong nuclear force. The strong nuclear force can exist within the range of a few femtometers. While the size of a proton is less than 1 femtometer, the strong force also leaks outside the proton. This strong force overcomes the electromagnetic force, so 2 protons stick together instead of repelling each other. If we try to kick out a quark from a baryon, it requires a lot of energy. Gluons are constantly exchanged between quarks and create a tube-like structure. This tube is very strong. When providing energy to try to eliminate one quark from a baryon, it acts like a spring or rubber band. The more energy given to pull the quark, the stronger it becomes. But anyhow, if we provide enough energy to remove a quark instead of kicking it out from the baryon, it creates a new quark, an antiquark pair. This pair is called a meson. This is how these new particles form.
आपको दूध भी नहीं दी ना?
And where E is equal to mc squared comes into play. The energy used to expel the quark from the baryon is converted into mass, so the extra energy creates a meson. However, mesons decay quickly. The exchange of mesons between 2 baryons is also responsible for same charged protons and neutrons stick together in the nucleus, responsible to mass. So the energy used to expel the quark from the baryon is converted into mass. So the extra energy creates a meson. However, mesons decay quickly. The exchange of mesons between two baryons is also responsible for same charged protons and neutrons stick together in the nucleus. However, we have never found an isolated quark or a particle with 4 quarks. And another thing, if we calculate the mass of all 3 quarks, which exist in a proton, they appear to constitute only 1% of the proton's whole mass. So where does the proton get this extra mass from? Well, gluons are massless and interact at nearly the speed of light. The energy between quarks converts into mass when we measure it.
Introducing Grammarly, like you've never seen before. Your all-in-one writing essential. Recycling is great for bottles, not borrowed sentences. Grammarly's plagiarism checker helps you stay original by catching borrowed lines before they slip through. Here's how it works. Once your draft is finished, click on the plagiarism checker icon in the side panel. It checks the writing against a massive database and flags any copy.
So far, we've looked at quarks, gluons, and the strong force, which are responsible for creating the nucleus of the atom. However, an atom contains both a nucleus and electrons. So what is an
हेलो
electron?
यार, इतना खतरनाक साइंस है कोई पढ़े